So hello students, welcome back again to our YouTube channel. So today we are going to do the second part of our topic, that is refraction of light. So as we done in previous session, we have done till the lenses, about the focus of lenses. Now we are going to move forward to the image formation cases. So image formation cases are basically both the cases, both the lens, that is concave lens as well as convex lens. So basically we have two lenses, so they both have different properties. So firstly the concave lens is thicker from edges and thinner from the center, and convex lens is opposite to that. So that is thicker from the center and thinner from the edges. So in these lenses, the image formations will be different. Image formations will be different in both the cases. So here it is a diverging lens. It will always diverge the ray of light, whereas the convex lens is going to be converging lens. It will converge the light to the another part like this. So this is going to be the focus, where the rays really, that is called real focus, as well as the focus on which we are virtually meeting the rays, that is going to be the virtual focus. So I hope these topics are clear to you. So we are going toward the image formations. So first of all, we are going to make the image with the help of a convex lens. There are 6 cases, like in the mirror in first video, as we have done in mirror cases. So firstly, convex lens. First case is case number 1, that is object is at infinity. So firstly, lens is placed, principal axis passes through the lens, object is placed at infinity like this, rays from infinity, they will refract back and meet at a point called focus. So this is going to be a real, inverted and point sized image. So this is going to be the first case of the image formation in convex lens. So here we have the object is placed at infinity, object is coming from infinity, the rays of light is coming from infinity and meeting at a point that is known as the focus. This is known as real focus, where the rays meet really at a point that is called real focus. So this is going to be the first case in which rays are coming from infinity and meeting at focus, and the image is formed real, inverted as well as a point sized image. So in this, the object is bigger and the image formed is smaller in size. Object have a large size, whereas image has a small size. So this is going to be your first case. I hope this is clear to everyone. So moving toward the next part, that is case number 2. Object is placed far behind center of curvature. So in this we are going to have an object that is placed, object is going to be placed behind 2f. This is O, this is F, this is 2f, or you can say R, C, 2f, anything you can say. This is radius of curvature, center of curvature, as well as 2 focal length. You can say anything to that. So our object is placed at this position and the ray incident passes through the focus. Second ray will be passing through optical center, meeting at a point that is in between focus and 2f, meeting in between f and 2f. The image is real, inverted, small in size to the object. So in this, so first of all, object is placed behind 2f or R. When object is placed behind 2f, first ray that is incident parallel to the principal axis will passes through the focus, as well as the second ray will passes through optical center and it will reflect back to the optical center. This is going to be form a image that is in between f and 2f. Image position is going to between f and 2f. So larger the object, smaller the image. If the distance of object is larger, then the image distance will be smaller always. It is inversely proportional to each other. If the image is greater, the image of size is less, as well as if the size of object is less, then the size of image will be greater. So this is going to be the inversely proportional directions. ठीक है? So third case is going to be the object is placed at 2f. Case number third, object is placed at 2f. So if object is placed at center of curvature or radius of curvature, what is going to happen? So firstly, placing a lens, making principal axis. So 2FCR. Focus, optical center passes through, something about. This is going to be 2FRC. This is going to be the focus. Same in previous case, the ray diagram will be same as it is. First ray that is going to parallel to the principal axis will pass through focus, and the second ray that is coming from optical center will always pass through optical center. And the object, when object is placed at 2f, it is going to be real, inverted, same in size, as well as real same sized. This is a new term for everyone, real same size. Real same size means the size of object is 5 centimeter, then the image is also going to be of 5 centimeter. If my hand is of 6 inches, 7 inches, then the image formed of my hand to the lens will always be 6 or 5 inches. So what is the distance? That will be going to be the distance of image. So this is same in size as well as real same size image. This is going to be your third case. I hope this is clear to everyone. So next case is going to be the object is placed between f and 2f. So f and 2f case. So here we are going to have a new diagram. Characteristics of image is going to be same in every case, that is real, inverted, but the size of image or size of object is going to change in every case. No size will be same in any case. In first case it is point size, in second case it is small in size, in third case it is going to be same in size, in fourth case it is going to be the bigger in size. So you should remember each and every characteristic of image. So this is going to be focus, this is going to be 2f or c, and object is placed in between them. So first it is going to be this, second it is going to be this. So this ray is wrong. I'm going to make it again. This ray is wrong. I'm going to make it again. So this is going to be this. So here it is f, here it is 2f or c, here it is image. So here it is image, it is far behind 2f. Okay, so here it is far behind 2f, the real inverted. So if image here the size of object is 5 centimeter and the size of image is going to be bigger, like 7.5, 8, 9, any one. It is going to be any one. If you are going to put it in a lens formula, you will get an accurate value. So this is going to be the value. Okay. So the next case will be your case number 5. Object is placed at f. If the object is placed at f, what is going to be happen? So for that it is going to be a different image. For that, firstly lens is there, optical center is there, principal axis is there, f is there, 2f or c is there, object is placed at f. They will meet at infinity. The rays which are going to be passing through the lens, it will always meet at infinity. They will never meet at a single point. It will meet at infinity. So image is going to be size, bigger size, real, inverted, and image is going to form at infinity. So the mostly question is coming from this section, that what is happening if the object is placed at f. Mostly MCQ is there, in which they ask that what is going to happen when we place an object at f, or if we are placing an object at same focal length. So same focal length means the object is placed at f. Okay, so this is going to be the case. Here there is no real midage. It will meet at infinity. It is going to at the rays are going at infinity. Rays are going to infinity. They will never meet at a single point. They will meet at infinity only. Okay, so this is going to be your fifth case, and the last case for the convex lens is object is placed between F and O, optical center and focus. When the object is placed at optical center and focus, what is going to happen? It is a single case for convex lens in which the image formed will be virtual, and it is erect also. Virtual and erect image is formed when the object is placed in between F and O. So what is going to happen? A lens is there, and optical center, focus, object is placed in between them. So first ray is coming and passing through focus, second ray is coming, that is passing through optical center. They meet at a point where the image is formed. They will never meet really. But if we want to make an image, we have to make them meet virtually. So this is going to be virtual image, virtual, erect, and bigger size, and form a image in same direction of object. So this is going to happen in this case. They will never meet. They are going to separate out. They are going to separate out like this. If the ray is going this ray is going this. The distance between the rays is going to be more and more as it moves. So this is going to be the virtual image, and the case and a single case of convex lens in which the image formed is going to be the virtual image. So these are characteristics of image. By this we have completed image formation case for convex lens. So for next part we are going to have image formation case by concave lens, and it is going to be a single case only which is considered, which we are going to make, that is concave lens. For concave lens we are going to have a image formation. So image formation will be like this is going to be our concave lens, this is going to be our optical center, this is going to be our object, and the ray will diverge, second ray will pass out like this, okay, and from diverging part we are going to make a virtual ray, where the virtual ray and real ray will meet out. This is known as the image. It is always virtual, erect, smaller in size. So this is the first and last case of image formation. By this we have completed our image formation part of lenses. So with this your image formation or ray diagrams are over. So with this we are left with lens formula as well as power of lens only. So as we have done in mirror, the mirror formula in reflection part we have done with mirror formula which is 1 by f is equals to 1 by v plus 1 by u. So this is our mirror formula, by which if we have two quantities, then we are going to calculate third quantity with the help of this formula for the mirror. So for the sign conventions, in length, sign conventions in length, so it is going to be the same if we are moving from optical center to the direction of this is going to be negative, this is going to be positive, this is going to be positive, this is going to be negative. So these are the sign convention which we are going to use in the mirror, the lens formula. So what is lens formula? Lens formula is also a relationship to find focal length in lens. So what is lens formula? It is going to be 1 by f is equals to 1 by v minus 1 by u. Instead of adding 1 by v plus 1 by u, we are going to make a subtraction between 1 by v minus 1 by u. So this is going to be the lens formula. And the most favorite question of physics is going to be, what is the relationship between lens formula and mirror formula? So the main relationship between, relationship is going to be only we are going to calculate focal length by using both the formulas. So here what is going to find, here what we are going to find. So in this we are going to find 1 by f, here we are going to find 1 by f. So relationship between them is focal length finding only. So this is going to be the main relationship between lens formula and mirror formula. They both help us to find focal length. So this is going to be our mirror lens formula. 1 by v minus 1 by u is going to be our lens formula. So moving toward our next topic, that is going to be the power or magnification. So here magnification is also going to same minus v by u. Magnification of image, magnification power m is going to minus v by u. Okay, the size of image to the size of object. So this is going to be our magnification power. And power of lens, power of lens is going to be 1 by f. Reciprocal to the focal length is going to be your power. So with this our topics are over. So if the question come with the unit of power will be diopter. What is going to be the unit? Unit of power is diopter in lens. So power of a lens is calculated in diopter. It is a relationship between 1 by f. This is going to be your power. So with this we have completed each and every topic of refraction, as well as in first video we have completed. So with this all, lecture number 1, which is going to be reflection part, lecture 2, refraction part 1, lecture 3, refraction part 2, along with conceptual question. Lecture number 4 is going to be most important lecture. In this, we are considered to do some numericals related to this chapter, and lecture number 5 is going to be test part for students. A short video. In this, we are going to conduct a simple test which is based on MCQs. These are, in this we are having 15 to 20 MCQ which the students are advised to practice. If you practice these 15 to 20 MCQ, because the pattern of board exam changed, pattern of CBSE exams changed. They shifted exam 50% MCQ, 30% subjective, 20% internal. So this is going to be your new pattern. So with this, the most of the MCQ is going to be from the part of physics, because in bio there is no more MCQs. In that they are making a 30% subjective part from bio as well as chemistry, but most of the MCQ are going to come from the part of physics. Rather they are in the form of MCQ, rather they are form of numericals. Numericals are also coming in the form of MCQ. In next video we are going to have a quick revision of that, how numericals are coming in MCQ form and what are the disadvantage of numericals in MCQs. So we are going to have a next video for that only. So in this we are covered each and every topic, and some of the important questions are like as we have discussed earlier, for like that, what is the reflection? So question number 1, that is, what is reflection? Second, what is refraction? Third, what is total internal reflection? Fourth, what is critical angle? Fifth, what is relationship between lens formula and mirror formula? Sixth, explain about term magnification. Seventh, explain about concept of power of lens. Eighth is going to be explain about mirage. Why ray diagrams are important. Explain about cases of real image in mirror. Same for lens. How virtual image is formed in concave lens. So 13th question will be explain about real focus. 14, explain about virtual focus, explain process of focus formation, explain about refractive index, explain about Snell's law, explain laws of reflection, explain laws of refraction, explain function of normal ray, explain glass slab experiment, and your last one is going to be focus over your refraction is different from reflection. How? So these are 22 questions which are going to be the most important questions of this chapter. So I think so no more question is going to become in exam, because these are the question or based on the topics. So you should practice these questions. For next video, wait for some time. We are going to make a next video for numerical parts. In that video we are going to solve only numericals, and also I am going to explain how numericals are coming in MCQ forms and what is the disadvantages that are going to happen when the numericals are coming in MCQ form. So this is going to be the important questions. I hope all questions are clear to everyone. If you face any kind of problem in these questions, do ask me in comment box, so that we will make a separate video of your doubts. So please like, share and subscribe to the channel, and also it is a request to every student, please share this video to your colleagues, to your friends, to your classmates, so that they also learn from this video. So this is going to be the last part of the video, and these are the some of questions which you are going to face in your exam. These are the questions which are really important for you from the point of view of exam, as well as for your future studies. These are the questions which are going to be in +2. These are the questions which are going to be in your degree. These are the questions which you are going to face in your final exam of 10th class. So please, each and every student is requested to solve these questions. If you face any kind of doubt, if you face any kind of query in these questions, do comment in comment box, so that we will make a video for that. And this is going to be the last part of video. Thank you. Have a nice day. Stay learned.